Okay, so in your guys' atomic model, how many electrons can fit on the first energy level? 2, perfect. How about on the second? 8, very good. On the third? 18, very good. That's a question. You guys should know how many should fit on each energy level. Each energy level, you got 2, 8, 18. So feel free to copy this in your notebooks if you guys want to. You should have it memorized already. You got 2, 8, 18. Now, if you guys got the answer correct, or you feel confident about the answer, just hold on to it. Don't show it to me yet. I'm going to work it out on the board for you guys, and then I want you to compare your answer to my answer. So before I put this answer up on the board, give you guys about 30 more seconds, 30 to 45 seconds, for you guys to go ahead and get the correct structure for this atom. Remember, it has to be exact. I want the exact number of protons, exact number of electrons, exact number of neutrons. Real quick brain jog. In the middle, which of those particles, protons, neutrons, electrons, which ones go in the middle?
Protons and neutrons.
Protons and neutrons, very good. Quick little brain jog. What's the little brain jog we use? You keep your friends, people that are positive, like protons, or people that are neutral, don't hate you or don't like you, keep them in the middle. All the negative people, or negative electrons, keep them on the outside. Keep them on those rings. Keep them on the outside.
I can't draw a circle with this one.
Do your best. Okay, so protons, neutrons, electrons. Okay, so real quick. Okay, how many protons go in the middle? 27. There should be 27 black dots in the very middle. How many clear dots or neutrons should be in the middle? 32. 32 neutrons. There'd be 27. I got it. Okay, so 27 is the number of protons and the number of electrons. So, real quick, watch me as I fill up these energy levels. You got 27 electrons. The first energy level can fit. I'll help you guys better, because, alright, on the outside, I want you guys to count. How many electrons do you have on the outside of your outermost energy level? On yours. On yours. Who's got 16? Raise their hand. Who's got 19 on the outer? Who's got 18? Who's got 17? Okay, if you have 17 electrons on the outermost energy level, you've put it incorrectly. Let me illustrate. So real quick, I'm going to put 27 black dots in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 27 protons, black dots in the middle. Now we need 32 neutrons in the middle, because 59 minus 27 gives me my number of neutrons. I have 32 neutrons. I'm going to put those in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 32. Got 32 neutrons in the middle. Now that leaves me with 27 electrons. I know there's 27 electrons. So let me just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 5, 6, 7. Okay, this is for those of y'all that are visual. I'm going to fit these 27 electrons into my energy levels. So I got the first energy level. How many can the first energy level hold? 2. 2. 1, 2. What about the second?
8.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. How many came from the third? 18. But how many do I have left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Yours look nice.
So, got this. Perfect. This is what I'm looking for.
So why did you say it was incorrect if we had 17?
You said what?
Yeah, what?
You said it, if you said we had 17 on the 30.
Yeah, on the 30. If you guys had 17 on the outermost energy level, that lets me know that you guys counted it correctly. Because there's 2 on the first, 8 on the second, and 17 on the outer one. Does that make sense? So as long as you guys did just like that, you guys are good. Okay, so real quick, why don't you guys go ahead and erase your whiteboards? We're going to do something a little bit different. I'm going to teach you guys. Question.
How many were supposed to go in the around it?
You got 2. How many electrons?
Yeah.
There's going to be 27 electrons because of this number here.
Okay.
27 electrons. Okay, so erase your whiteboards. We're going to do something different. I'm going to teach you guys one of the most trickiest concepts in chemistry. It's called significant figures. There's some chemists or some chemistry majors in college that still don't understand this concept, but you guys are going to understand it, guarantee you. Okay, first of all, I want you guys to draw the United States, the country of the United States, on your whiteboards. Do your best. Just don't make it look like a potato. Do your best to illustrate the United States, the country, not the flag, on your whiteboard. I want you guys to illustrate the United States on your whiteboard. Looking for the country. It's pretty good. It looks a little chunky here in the United States. A little rotund around the edges. Sum it down. There you go. I like that. I like that. You guys hear what Mr. Ramirez said? His United States was kind of fat, but kind of a little rotund. But because he says that we're the biggest country apparently.
I can do it in Texas, I think.
I want you guys to draw the United
That
States.
look like a handgun.
The United States.
It said we eat too much of McDonald's.
Who says you eat too much McDonald's?
TV.
TV tells you to eat too much McDonald's.
They say we eat a lot of junk food. I see them showing people on McDonald's.
You eat a lot of junk food? That's good. Actually, no, I like the other one better. That's good too.
You're forgetting 2 states.
Excuse me. Okay, so,
Like a cow.
oh, you're there. Okay, so real quick. These are the closest ones to the.
You forgot Alaska.
Okay, so take a look at this. Even better. So, this over here, you guys tell me that looks similar to this? Or, even better? This one's still good. So you have the United States here. What does it look like to you guys?
A burrito.
Looks like a burrito? What does this look like to you all?
Looks like a tree.
Watch those. Those whiteboards cost $5 a piece.
That looks like an upside down burrito.
What does this look like to y'all?
Cake.
Cake? It's like cake. Cool. It's like cake, but this is the U.S. Okay, on you guys. Anyone else want to show their board? Okay, here we have U.S. and of course, who all has been over here? Who all has been to Alaska? Anyone been to Alaska?
I seen it on TV.
Seen it on TV? It's good. Okay, so real quick, I want you guys to write down Pacific. I want you to label the ocean. Pacific Ocean and Atlantic Ocean. Don't erase your state. Your state, or the country states beyond it. In order for you to get significant figures, I want you guys, you can't erase your United States, you need this in order to get significant figures.
How many are there?
Well, don't label all the oceans. All I want is the Pacific Ocean label and the Atlantic. That's all that matters. Just the Pacific and the Atlantic. Hey, I'm cheating. The Pacific and the Atlantic. So be sure you don't erase your United States. I want you guys to label the Pacific Ocean and the Atlantic Ocean. Don't worry about Canada.
I got them wrong.
Okay, think about this. Who else been to California?
Nope.
Who's traveled the Pacific Coast Highway, PCH? So, think about California being the Pacific. So that means that where California is at, that's where the Pacific Ocean is. Talking about left and right. Left and right. So on y'all's whiteboards, you guys should have something that looks kind of like this over here. You draw a quick little US. I'm going to label it. I want you guys to label it. You guys know it like this.
How does Texas look?
Looks like a pizza.
Texas is the real estate where.
So you got the United States. Thanks. That's good shirt. It's a pretty yellow shirt. Okay, so you got the United States. You got the Pacific Ocean. You got the Atlantic Ocean. Why don't you guys draw a line straight across? Line straight across, just like that. Okay, so for significant figures, all you guys need to do ever is just to know this. This is kind of common sense. Once you guys do this once, you already know the United States, what it looks like. You already know what the Pacific is and where it's at. And you know what the Atlantic is and where it's at. If I give you guys a number like this, if I give you guys a number 0412.00, you need to tell me on the test and also on your quiz how many significant figures there are in this number. Let me show you guys how you use this map to do that. Okay, first thing you want to do is, you got P for Pacific, P for present. I want you guys to write that down just like that. You got A for Atlantic, A for absent. I want to tell you guys a story. Who of you guys are huge history buffs? Who's big on history? What does this line represent in the world of history? Could represent a couple things. Could represent equator, what else? Division, the North and South Confederacy. What else? Looking for a little bit something specific. South North is a little bit different. Let's see.
I know what you're talking about.
Democratic and political.
Kind of on the right track, but looking for something that you write. What do you write? Back in the day.
Country.
Choo-choo.
Country.
Train. So, here, I said choo-choo. So, choo-choo train. Okay, so you got a railroad. I went to left or right. You guys are going to use this to answer this question here. So real quick, if I ask you how many significant figures are, all you have to do is ask yourself one thing. Is the decimal present or is it absent? In this number, is the decimal present or is it absent? It's present. It's right over here. Since it's present, you're going to start on the Pacific side, P for Pacific, P for present. Sure. Okay, so if I ask you how many significant figures there are in this 1, 2, 3, 4, 5, 6 digit number, all you need to ask yourself first is it decimal present or absent? If there's a decimal that's present, you can start on this side, P for present,
What do you mean?
P for Pacific, I'm going to tell you. P for present, P for Pacific. You start on this side, just crossing out all zeros until you come to a number that's not a zero, and every single number past that counts as a significant number. Don't think too much into it. Don't think too much into it. It just is what it is. So, real quick, I'll do a quick example again. So I got a number like this. I got 00412.00. First thing you want to ask yourself when you look at this and I say how many sig figs or significant figures are in this, is the decimal present or absent? It's present. Start on this side, P for present, P for Pacific. That's why this can kind of help tell you which side you start on, the left or the right. Because all you do with significant figures, you're either going to start on the left or the right, crossing out zeros. So P Pacific, P present, decimals present. You can start on the left side, crossing out all zeros. So I come to a number that's not a zero, everything past that counts. How many significant figures do I have?
5.
Got 5. Very good. Now, real quick. We use that same number, but what's different? There's no decimal. Is the decimal present or absent? It's absent. So if it's absent, which side do I start on? This side, crossing out all numbers, all zeros, so I come to a number that's not a zero, everything past that counts. How many significant figures? 5. Got 5. Remember, everything past it counts. All I do is cross out zeros, so I come to a number that's not a zero, everything past that counts. So, real quick. Well, the thing is, like, if it's for significant figures, all you have to look for is if the decimal is there or not. There's no implications. There's no implying that it's there or.
So everything basically with
No.
Yeah, if it's there, it's there. If it's not, it's not. So, for example, take a look at this number. You got 1,000. Is decimal present or absent? It's absent. It's not here. I mean, it's implied that it's there, but I want to know physical proof. If the decimal is physically not there, it is absent. So you start on this side, crossing out all the zeros, so you come to a number that's not a zero. How many significant figures? 1. If I got a number like this, is the decimal present or absent? It's absent. Start on this side, crossing out all zeros, so you come to a number that's not a zero. Everything past that counts. Got 2. You got something that looks like this. Got 1 million. Is there a decimal present or absent? Absent. You start on this side, crossing out all the zeros, so you come to a number that's not a zero. 1 significant figure. Okay, if I got something that looks like this, is the decimal present or is it absent? It's present. So on this side, crossing out all zeros, I come to a number that's not a zero, everything past that counts. How many significant figures? You got 6. If I got this number, how many significant figures?
What? Oh, wait.
How many significant figures is this? Okay, decimal's present. Start on this side, crossing out all zeros, so I come to a number that's not a zero. You got 4 significant figures. Does this make sense? Okay, cool. So we're all good? Okay, now you guys have understood and learned pretty much one of the trickiest concepts in chemistry called significant figures. I guarantee you, if you ask a chemistry major, go to UTA, go somewhere, ask a chemistry major, hey, you know significant figures, and ask them if they can show it to you. A lot of them, they don't really understand, they don't really get it, because it's not so heavily emphasized in college, but for some reason, a lot of people can't really get that. So if you guys got that, awesome. Very proud of you guys. Very good. You guys are going to have to need to know this on the test. So this is kind of just a quick memory jog to help you guys out with the test. Okay, so for the test, we've knocked out significant figures. We've knocked out illustrating atoms, what they look like. Real quick, for scientific notation, remember what I said earlier, if you guys cannot get scientific notation down, you're not going to pass this class. Because from here on out, in the future, all your answers are going to be pretty much in scientific notation. Because we're dealing with real big numbers. What's the purpose of scientific notation? To make larger numbers manageable.
Oh.
Once we get into you guys knowing exactly how many atoms make up this beaker, there's a lot of atoms that make up this beaker. You guys will know exactly how many. It's going to be a huge number. So in order to express that real big number, you're going to need to be able to put that number in scientific notation so you can manage it. So real quick, you got a number like this, 1 million. Put that into scientific notation. How would you do that? First thing you want to do is decimal what? Always comes in second place. The decimal's over here. It moves over 1, 2, 3, 4, 5, 6 places. So it's 1 times 10. How many places did it move? 6 places.
Like this, like this.
Perfect. That's 1 million in scientific notation.
Because 1 times 10 to the 6th power is 1 million.
Exactly. So if you got a number that looks like this, as you put in scientific notation, where's the decimal at? It's at the end, but you want to be in second place, which would be behind the 1. That puts you at 1.2 times 10. How many places did you move over? 1, 2, 3, 4, 5, 6. 1.2 times 10 to the 6th power. Okay. So, real quick, I got a number that looks like this. Don't let these numbers fool you or trick you or throw you off. If I got a number like that, I ask you to put this number into scientific notation.
Is that an 8?
The decimal's right over here. Decimal just wants to be in what place? Second place. So you move over 1, 2, 3. So it's 1.012 times 10 to the third power. That's your answer. He just always wants to be in second place. Simple as that. Don't let zeros or any other numbers throw you off. He just wants to be in second place. Cortez, Sazon, make sense?
Yeah.
Okay. So if I have a decimal like this, if I have 0.0001, the decimal also comes in second place. Where's second place at? It's beyond the 1. It's right over here. Remember, he wants to follow a real number, so he's going to move over 1, 2, 3, 4 places. There's 1 times 10 to the what? Negative 4. Negative 4, because he moved over to the right. If you move the decimal to the right to get to second place, it goes negative. If you move it to the left, it just stays positive. Okay, so real quick, throw another one. If I say 0, 1, decimal, 0, 1, 2, once you put that in scientific notation, where's second place at?
It's already there.
It's already there. Very good. He's already in second place. All you gotta do is get rid of this.
Move it back.
You have to move it anywhere. All it is in second place. Yeah, you just keep it as 1. Oh, sorry, you keep it as 0. So it's 1 times 10 to the 0 power, because it just stays in the same place. Okay. I got a number that looks like this. 0.026. Once you put that in scientific notation, where's second place at? You're on that 2. So it moves over 1, 2, 3, 4 places. So it's 2.6 times 10 to the negative 4 power. So that's putting numbers into scientific notation. You guys need to also know how to put numbers out of scientific notation. So if I give you a number that looks like this, if I give you 2.6 times 10 to the 8th power, take that out of scientific notation, what's that going to look like? You got 2.6, you're going to move the decimal place over how many places? 8. It's a positive 8, so it's going to be a bigger number than 2.6. So move it over 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So it's 260 million. You just can't have times it move. Yeah. So it was right here. So you move over 1, 2, 3, 4, 5, 6, 7, 8. And now you're taking this number out of scientific notation. Say we still have the same number. Well, let's turn it into a negative. Negative. Now the decimal is going to move over 8 places to which way? That way, because it's going to be a smaller number. 2.6 needs to be smaller. It needs to be smaller than 2.6, so to make this number smaller, move it over to the left. So you had 2.6 right here, you move it over 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. It looks like that. That'd be your final answer. Does it make sense? Is it making sense? Any questions? It's called scientific notation. So remember, you got that scientific notation mastered. If you don't, you're not going to make it to this class. So it's real simple. Positive, you guys pick up this not count. Okay, so on y'all's quiz. You got chemistry quiz number 9. I want you guys to jump down, skip over down to this part right here. Take a look at the chemistry side. Actually, you know what? Let's knock out scientific notation first. So, take a look at your quiz. Take a look at your quiz. Yeah. So, take a look at your quiz on the scientific notation part, worksheet on the other side. I want you guys to answer these scientific notation questions. It's on the back side. It's this side over here. On the back of your quiz 9, I put a little worksheet assignment. I want you guys to work on that first. Then we're going to come back and hit up the first part of y'all's quiz. Okay, so I want you guys to go ahead and work on that worksheet side of it. Work on the worksheet side of it. Yeah, that's fine.
Okay, you want us to skip down to number what?
So take a look at this side over here. You got your quiz. On the other side, there's a worksheet that I copied onto your quiz. I want you guys to work on this first.
Okay.
And now I got a scientific notation. Be sure you master this. Master this side. Scientific notation.
Could you come here first?
Yes. That's for significant figures.
Okay, so with this, 42, 1, 2, 3, 4, 5,
See, so yeah, so basically so the decimal, where's the decimal at right now? Without even moving it. It's all at the end of the number. Very good. So you move it over 1, 2, 3, 4, 5, 6.
Okay.
So it's going to be 4.2 times 10 to the 6. Perfect.
All right, thank you.
Yeah.
Yeah, it's going to be negative. 1, 2, 3, 4, 5, 6, 7, 8 places. So it'll be 1.5 times 10 to the negative 8.
So that, C4. Perfect, very good. That was perfect.
Did this number have two different?
No, that's the period at the end.
Oh.
Number 2 is the period at the end.
Okay.
So the decimal is over here at the end. You moved over 1, 2, 3, 4, 5, 6 places. This is 4.2 times 10 to be 6. Oh, it's going to be, because the decimal wants to be in second place. That'd be first place. He wants to be in second place. So the decimal is like one right over there. And that's what starts. Well, it wants to go into second place. So it's over here and it wants to go into second.
Looks great. Hey, what you need to start?
Well, the decimal is right over here. Because, oh, this is actually this is where it's so that's the so the decimal is right over here. So it doesn't mean-
I know where it's at. That's
Exactly.
they stuff. Yeah. Do more. Go with Jason. Jason, I did. It don't look right.
Yeah. Question. Okay. Is this your second ticket course with us? Yeah, so that's scientific notation. You're on the right track, so basically you're trying to put this number in scientific notation. Where's the decimal? It's going to be here. So it moves over 1, 2, 3, 4, 5, 6 places. Yeah, because it's almost in the second place. Because it has to be, and then you have to have a decimal point there. Yeah. Very good. Yeah. 4 looking.
Okay, so okay, so for number 3, yeah, 60,000 miles, 150 scientific notation. So this number here 60,000. Where's the decimal line? 60,000. The original. The very end. It's going to move over into second place. We're second place out. Right behind 6. Every second place. It goes over. 1, 2, 3. Oh, that's significant figures. Yeah, this is scientific notation. Sig fig is something totally different. So remember, with scientific notation, all you want to do is decimal wants to go in the second place. You can even write that in your notes as a memory jog. The second place, decimal wants to go in the second place for scientific notation. So it's going to be right there. 1, 2, 3, 4. You move the full place, just need 6. Times 10 to the what power? 4. Because you need the full place to get started on that. And put over 97. Remember that. Perfect. So it's going to be, that's correct. So it's going to be, the answer is, perfect. No, I said no. I said no. Times 10 to be 4. Very good. Second place. Perfect. Right down that one. See, right down that one. I want to figure out.
You don't have no hand sanitizer?
Perfect. Very good.
How do you know when you stop?
Now you're going to do
How do you know when you stop?
stop. Because you always want to be in second place. So I just remember, that's when I see the second place.
That would be
This number over here, where's second place? Where's second place at? Move way, when we're talking about, he wants to be in second place, but he wants to follow zero numbers, not zeros. He wants to follow numbers on paper. Yeah, so goes right there, that's second place right there. You're right in that one. Where's second place over here?
You gonna play soccer?
There you go, 1.9. Where's second place here? Perfect. Second place here? Perfect. Number 2. Let's see. This is taking me with that too.
Can we just do 1.6? Do we have to add the rest of it?
Yeah, that's perfect. 1.67 3 times 10 to be negative 10. That's perfect. Yeah. Perfect.
Let's see. Like a brain day. What class are you gonna try? We always bad.
Is there, how many zeros are there on this one? This is perfect. Very good. Excellent work. 100%.
Yes.
I'll probably get like so too crazy. Yeah. To the sacrifice, lasting everything. I like your shirt. Thanks. I have it. No. Oh, my shirt. That's fine.
Yeah, so,
I can go buy me some dry shirts.
you know how these things work, right?
Shop
Yeah, so basically, there's an essay that's due every single week. You can use these this week, next week, and the following week, instead of having a whole page essay. You can use this one for the rest of your So you can use it for the restroom or use it to.
You want to see the back?
You can do it outside.
You did.
Give me 1 second till the test gets back. Hold on 1 second.
What's the name? So what is number one negative?
Once you compare the Xavier, Xavier has one regression. So that's positive.
You should compare.
I'm talking
Correct. Perfect. You're good. That's perfect.
Oh, what you doing?
See, this would actually be simple.
No, well, it's right,
You're gonna look at it. You just stand at the door.
grab a seat. Yes, we're on this.
Significant figures, but we use the United States. United States, the significant figures. So remember we did with the significant figures, significant there was walking figures. Draw person wants to walk. In the United States, Pacific is over here.
White from me, I see.
So the United States.
First, she
So
left.
you want to basically look
She's
at
gonna
the
look at the
number,
buttons.
see if the decimal is present. The decimal present here? It is. So you start on this side, crossing out all zeros, you give the numbers not zero. Because this one is absent. This one on that side, crossing out all zeros, you can bring this one as zero. And yeah, two. And then this one. Because remember, you start on this side, cross out all zeros. Because this one is present, P for present. Start on this side, crossing out all zeros, it becomes non-zero.
That's what it's going to be.
It's gonna be 5.1 times.
This one's present. All the counts.
Oh, zero.
So this one is present, so you cross out all zeros. What about this one?
You was talking about people.
This one's present. So on this side, safe side, crossing out all zeros. You just kind of approach these questions by using your this map over here. So you always want to test that as a president, right? President, right? President. I'm going to draw a couple more on here. You tell me if it's a good total.
Yes, one.
You tell me how many significant figures are on each of these over here. All you want to do is ask yourself, is decimal present or absent? Absent, you start on this side. Just crossing out all zeros. If it's present, start on this side, crossing out all zeros. Present, start on this side. We'll come back at you. Question? Who's got a question? This is what else you do. You're right. significant figures? Okay, once you keep working on this, I'm going to come back to it. I'm going to do it on the board. Any more questions on scientific notation? Everyone got on scientific notation? Everyone got on scientific notation, correct? Okay, so real quick, for significant figures, let's work on this together. So go ahead, turn your page to the back to the other side when you're done with scientific notation. Okay, number one, you have this number here. You have 5.40. Remember, this is significant figures. With significant figures, you just have to know the difference between significant figures and scientific notation. Scientific notation is putting numbers like this out of this, whatever. Significant figures is the U.S. So all those things significant, the U.S. Think about significant, what's the significance of us learning U.S. history? What's the significance of us learning U.S. history? What do they say? Because we're Americans, so we don't make the same mistakes twice. What we do. That's why they make us learn history, because they don't want us to make the same mistakes twice. What's the significance? Significant figures.
World War II.
War II.
What are you talking about?
What are you talking about?
I know you're weird. Why you bring that up?
Okay, so anyways.
Show me what you mean.
So you got this number on your guys' questions. How many significant figures are in 5.40? First thing you want to ask yourself, is the decimal present or is it absent? It's present. So you start on this side, crossing out all the zeros, so it comes to a number that's not a zero. How many significant figures are there? There's 3. 3 significant figures. That's your answer for that one. Now let me just switch it up just a little bit. What if I just put a couple zeros here and took away this decimal? I said, how many significant figures are there? First thing you want to do, ask yourself, is the decimal present or is it absent? It's absent, so you start on this side, the Atlantic side, crossing out all zeros, so you come to a number that's not a zero, everything past that counts. You got 4.
What's up with numbers?
Number 2 is 2. Number 5 and 6, you got to work those. Well, number 5. Okay, so let's take a look at number 2. Number 2 is 210. Is the decimal present or is it absent?
Oh, it's
It's absent, so you start on which side?
on the right.
Crossing out all the zeros, so you come to a number that's not a zero. Everything past that counts. You got 2 significant figures. Does that make sense? Question Xavier.
You do number 6.
I'll do number 6. Alright, let me work on number 6 real quick. So you got 1.2, you guys already know the answer to this. You got 1.2 times 10 to the third. So 1.2 times 10 to the third, you first need to take it out of scientific notation. So you got 1, 2, 0, 0, move it over 3 places, 1, 2, 3. Okay, now you have to ask yourself, do you need a decimal here to express this number? You don't. So that's your number there. Is the decimal present or is it absent? Absent. How many significant figures? 2. And those ones are kind of tricky. Not ones like those. Yeah. So, but all I want you to do is just focus on significant figures, whether they're present or absent the decimal.
Number 5 and 7, 8.
Present. Correct.
Just go around.
Very good. Good work. You're answering how many significant figures there are. So sig fig, significant figures, think United States, significant of learning your United States history. So just correlate significant figures, significant with the significance of the U.S. And that'll jog your brain. And scientific notation is just putting things in bigger numbers, making them smaller, or smaller numbers, making them bigger. So, does that make sense? You guys are all good on scientific notation on this side, right? Remember, just be sure you guys remember the difference between scientific notation and the difference between significant figures. 2 different things. Okay, as you guys are wrapping this up, just answer a couple questions. Yeah.
On number 7, do you count the decimal? Like it's present, so you started with your pass the decimal.
You just cross out all zeros, so you come to a number that's not a zero.
So it's 5.
Remember, decimal doesn't protect anybody. Perfect. Very good. Sure. Is the decimal present? The decimal's present.
Oh, hell.
You start on the left side. You don't start on the left side of the entire number. I'll work at number 10 on the board. I'll work at number 10 on the board, so you guys understand that.